In this lab, management wants us to set up specific spanning tree protocol routes for specific VLANs. Specifically, management wants us to make switch 1 on the first floor the route for VLAN 1. And for the second floor, management wants us to make switch 1 the route for VLAN 10, switch 2 as the route for VLAN 20, switch 3 as a route for VLAN 30. So before we get into that, what exactly is Spanning Tree Protocol? Spanning Tree Protocol, or STP, helps prevent switching loops in networks with redundant paths. A switching loop occurs when there are redundant paths between switches, forming a circular path for packets to traverse continuously. For example, if switch 1 connects to switch 2 and switch 2 also connects back to switch 1, this sets up a loop. Packets forwarding from 1 to 2 will end up back at 1 again, creating an endless circulation. The major impact of switching loops is broadcast storms. Broadcast traffic is meant to only reach each network segment once. But a loop will allow broadcast packets to be forwarded endlessly. This quickly floods the network with excessive traffic and broadcasts. Switches become overwhelmed, traffic is delayed, and a network can grind to a halt. Spanning Tree Protocol prevents this by blocking redundant paths to break the loop. It ensures there is only a single active path between any two switches. This maintains connectivity without allowing loops that lead to broadcast storms. So essentially, STP blocks extra paths, so there's only one route between devices. STP also provides backup paths for reliability. If a link fails, a blocked path can become active. STP basically makes sure data flows efficiently without any loops. So let's first console to switch 1 using PC2. Now let's do a show run to see what type of spanning tree protocol we're using. The spanning tree mode is PVST. This sets the spanning tree mode to PVST, which stands for per VLAN spanning tree. Per VLAN spanning tree runs a separate instance of spanning tree for each VLAN configured on the switch. This provides optimization and load balancing across VLANs. PVST is Cisco specific, meaning other switches can't use this protocol. There are other types of STP, which include Classic STP, which is the original standard version of STP, which is vendor neutral, meaning it works on Cisco devices, Juniper devices, etc. This version has slower convergence when the network changes. Convergence refers to the time it takes for STP to recalculate the network topology and stabilize with new root bridge selections, port roles, and block ports after a change occurs. STP has to communicate these changes using BPDUs, and it redetermines the spanning tree roles. The time it takes for this process to complete and for STP to stabilize is called the convergence time. Rapid STP is faster in responding to changes and improves on the classic STP. This one, too, is vendor neutral. Multiple STP is similar to per VLAN spanning tree, but it can also group VLANs to optimize resources. It's more scalable and, again, vendor neutral. PVST is the Cisco specific protocol that runs a separate STP for each VLAN, which is the one we're currently using. PVST Plus is also a Cisco specific protocol and is an enhanced PVST, but it still uses the slower classic STP standard. Rapid per VLAN spanning tree is the other Cisco specific protocol that enhances PVST, but this one uses the faster rapid STP standard. Okay, let's get into global configuration mode and use the command spanning tree VLAN 1 root primary to make the switch to primary root for VLAN 1. The root primary command uses a macro, or a set of instructions run by one command, that sets the switch priority to 8192, or to the current primary's priority automatically. Why would it do that? Because in order to become the root primary, you need a low bridge priority. The range for bridge priority is 0 to 61,440 in increments of 4096. Lower numbers indicate higher priority. Priority of 0 would make a switch the guaranteed root bridge. 32768 is the default priority used on Cisco switches if the priority is not configured. To make S1 the root, its priority must be lower than the default 32,768. And 8192, or the current primary's priority number, which the macro set it to, is definitely lower than 32,768. Also, if two switches share the same priority, the one with the lowest MAC address would become the priority. For example, if two switches have the same priority value and their MAC addresses are 00, 11, 22, 33, 45, 55, and 00, 11, 22, 33, 44, 56, the switch with the MAC address ending in 55 will become the root bridge because its MAC address has a smaller numerical value. Okay, back to the S1 switch. If we do a show spanning tree command in privileged access mode, we can confirm that our S1 switch is now the root bridge. Notice that it says this bridge is the root, which means we've successfully made switch 1 the root for VLAN 1. Also, notice that the active interfaces on this switch are participating in spanning tree. They're all in the forwarding and designated state, which means they are actively transmitting traffic to and from this network segment to other parts of the network, away from the bridge, which is the switch. If we were to look at switch 2, we'd see different roles and states. For example, the link that goes to our switch 1 root bridge has the role of root, meaning this path connected switch 2 to the root. G02 on switch 2 is currently set to alternate and has the status of blocked because that link is being blocked from sending and receiving traffic in order to prevent a loop. If G01 were to go down on switch 2, messages called BPDUs, or Bridge Protocol Data Units, sent from the root bridge would reach G02. Switches send BPDUs with info like bridge ID and the path cost to get to a destination. The root bridge generates BPDUs and sends them to lower priority bridges. The information then gets propagated as bridges pass along BPDUs of the route, updating the path cost and age. So basically, BPDUs contain key information about bridges and topology that allow FTP to prevent switching loops. G02, after listening and learning from the BPDUs, would change its role to root and its status to forward. Okay, make sure to save your configuration back on switch 1. Now let's move on to the second floor. Use PC1 to console into switch 1. Let's do a show run and see what type of spanning tree protocol we're dealing with. Looks like per VLAN spanning tree again. Notice in the show run command that interfaces FA01 and FA02 have spanning tree portfast commands on them. These two interfaces are connected to the two PCs in this network segment. So what does spanning tree portfast do? Normally, when a switch is connected to a network, it has to listen and learn from Bridge Protocol Data Units, or BPDUs, that are sent from the other FTP switches before it can start sending and receiving information. This can take some time. But When you use spanning tree port fast, the interfaces on the switch can skip the listening and learning part and just start sending and receiving information right away by going straight to the forwarding state. Back to switch SW1. Let's get a current view of the STP landscape with a show spanning tree command. Looks like this switch, SW1, is currently the root for VLAN 1, VLAN 10, VLAN 20, and VLAN 30. But we only want it to be the root for VLAN 10 and a default VLAN 1. Okay, so even though it's currently the root for VLAN 10 already, let's change the priority number for VLAN 10 to a lower number to ensure it stays the primary. We lower the priority by using the spanning tree VLAN 10 priority 24576 command. Save the configuration. Now let's move our console cable to switch 2, SW2, to make that one the root for VLAN 20. Let's then put in the command spanning tree VLAN 20 priority 24576 to make it the root for VLAN 20. Let's use the show spanning tree command to confirm that this switch SW2 is now the root bridge for VLAN 20. If we scroll down to VLAN 20, we can see that it worked. Now save your configuration and we can move on to the last switch, SW3. Move your console cable to switch SW3. Then put in the command spanning tree VLAN 30 priority 24576 to make SW3 the root for VLAN 30. Let's verify that SW30 is now the root for VLAN 30 with the show spanning tree command. Looks like we're good. Awesome. Now let's save your configuration, save your packet tracer file, and update your notes. Then create your narrative. After that, share the Google Drive folder you have for this lab with the anyone with a link can organize, add, and edit access. Then submit the lab for review. If you don't know how to submit the lab, refer to the instructions in the lab's intro video section of this program. After that, you can move on to the next lab.